Hi students, welcome to Max Point of View. Till now we have understood the concepts, theory solutions and numericals of all the chapters, right? All the links are available in the description box. If you take an example of the first chapter 4, we have concept videos, the theory solutions and numericals of all the three parts. If you have seen and understood all the parts, then you have only 50 to 60% of the knowledge. Then where we are going to get this 40% of extra knowledge so that it will be very useful for our board exam. That is where previous year papers and expected logical and application questions comes into picture. We are not just going to give you the previous year paper questions as well as the solution. We have sorted it chapter wise. Will be chapter wise. From the first chapter, what are the previous year questions asked? Then work energy power from 2017 to 2025. If I give you the papers like that, okay, just with the sorted way, you don't understand the solution. Many students will by heart the solution. So, and you know, in physics the questions are never going to repeat, correct? So we need to understand the same question in many different ways. So what are the possibilities? They can ask the same question in any different way, so that we are going to learn the complete concept in a proper way. These previous year solutions we are going to solve chapter wise, and all the links are available in the description box. Why we are selecting the questions only from 2017? Why not before 2017? Why? Because before 2017, what were the concepts we had in the textbook? Many things are not there presently, and before 2017 the questions asked were not that logical. Okay, most of the questions are direct. Here now most of the questions are logical and only few questions are direct. Anyhow, you're going to get the solution for all these papers in some websites, correct? Then how it is different from our maths point of view videos? In other websites you will get the solution and many students will not understand how we got that solution. Here we are going to solve and train you for that particular question. Not only that, we are going to train you what if the same question is put in other different ways, so that we are going to train you in all the angles so that you will be perfect. Any question related to that in different way, you will be able to answer it. So without wasting any time, we'll start with our first question. Every year from the chapter 4, minimum of 2 questions are asked in board exam. So we'll start from 2017. See, why not before 2017? Why? Because the questions are simple, not that logical, and few portions which were there at 2017 are not here in our textbook presently. See, our first question in 2017, a brass ball is hanging from a stiff cotton thread. Draw a neat label diagram showing the forces acting on the brass ball and cotton thread. If you understand this question properly, the same concept is there presently, not in 10th standard, that is in 9th standard. That is why we are not solving before 2017. See this question, they are asking us to draw the label diagram of showing the forces acting on a brass ball. First, we have to draw a brass ball hanging from a rigid support using the stiff cotton thread. See this, and it has to be labeled diagram. So this is rigid support, okay, cotton thread, brass ball. Now the diagram is done. We'll go for the actual question, showing the forces acting on the brass ball and the cotton thread. See, we have cotton thread and the brass ball. Do you see any forces acting on them? No, right? So even though there are no external force applied on it, very simple. See, brass ball as a weight, right? Weight will be acting as a force. This we know. This is a very simple thing in physics. If no forces are there, weight will be the force acting on a body. Okay, force of the brass ball is what? Weight. Okay, weight, and this one will be in downward direction. Downward direction. Then on the thread, see, whenever there is a thread connected to some support and there is one something is hanging from it, there will be one more force. We call it as tensional force. What do you call it as? Tensional force. See, this is called as tensional force. So when the tensional force comes into picture, when a thread or a rope is connected to some part, okay, rigid support, then something is hanging on it, then we will get a tensional force. Not only in this example, whenever we talk about pulley, okay, in olden days we used to use pulley, right? We know, we have learned the concept. So in pulley system, we know one load and effort will be there, and there we have the support. Even though it has only one rope, see, the same rope is connected to effort as well as load, but how many ropes we can see? Two ropes, right? So two tension will be there, and the tension direction is always towards the rigid support or a support. So here how many ropes we can see? One rope, so that's why only one tension. Here the same rope is connected from load to effort, even though we can see two ropes, right? That means two tension will be there. So in block and tackle system, if we have around four pulleys, we will see five tension, correct? So in this way you need to understand. And whenever they are playing tug of war, this rope is going to pull in this direction as well as in this direction because of some people, correct? Where will be the tension then? Tension will be towards the center, see, this is nothing but the direction of the rope is pulled. Okay, these are the direction of tension. Okay, both the ways it is pulling, then tension will be towards the center, that will be acting as a support. This is how we need to understand. So this is tensional force. Tensional force in which direction? In upward direction. Direction also we have to mention. So this is our first question. So if you go for websites, you will get the answer diagram, and weight will be in downward direction, tensional force will be in upward direction. Some students will understand why the weight will be in downward direction in an easier way. Many students will not understand what is tensional force and why it has to be always upward direction. Can it be in downward direction? All those questions they will get. See, there is no direction for fixed direction for tensional force. Tensional force is always towards the support. This is the support, correct? This is the support, that's why it's going up. Here, see, this is the support, that's why it's going up. Here there is no support, fixed support, correct? But both the ways they are going to pull it. So center point will be the supports, that's why tensional force will be towards the center. Now a second question in 2017, the distance between two bodies is doubled. How is the magnitude of gravitational force between them affected? See, the distance between the two bodies is doubled. How is the magnitude of gravitational force between them affected? So this is the formula. I think you have learned this one. See, here F is the force between them. G is the gravitational constant. M1, M2 are the masses of two different objects, and R is the separation between them. Separation means distance between them. Okay, now we are talking about only force and separation, distance between them. We are not talking about gravitational constant, mass and mass of the two objects. That is not mentioned in the question. We are going to talk about gravitational force and their distance between them, only these two. Okay, even though all these things are there, they are constant now, they are not changing for presently. Okay, now only force, and they are talking about only force and the distance between them. Now see, you need to understand. Now I can directly go like this, correct? I can directly go like this. See, here these two are inversely proportional. If distance between them, what is R? Distance between the two bodies, if that is increased, force will decrease. Why? Because these two are inversely proportional. First we'll understand without this power, then we can easily understand. Now listen, if R increases 2 times, then force decreases 2 times. Why it decreases? Because these two are inversely proportional. If R increases 3 times, force decreases 3 times. Now in the question we don't have, okay, R, we have R square. We have what? R square. Now we'll understand. See, if R increases 2 times, see, this is not only for this question, all the question you can apply the same method. If now we have square, right? If R increases 2 times, 2 power 2, 4. Force reduces 2 times. See, initially when there was no power, how many times this increases, that many times this decreases, correct? But anyhow we have power now. What power? That is power of 2. Now if R increases 2 times means instead of R you write 2. What is 2 power 2? 4. Force decreases 4 times. This is how we need to understand. Okay, if R increases 3 times, if R increases 3 times in present case, 3 power 2 is 9. Force decreases 9 times. Okay, then in a ulta way, in other way, if R reduces 2 times, reduced to half, assume the distance between them is reduced to half, that means it has reduced 2 times, right? If R reduces 2 times, we know if R reduces, force increases, but how many times? That is very much important. If R reduces 2 times, then means 2 power 2 reduces by 2 times, right? So 2 power 2 is 4. 4 times force increases. If R reduces 3 times, this R reduces, R means distance between them reduces 3 times, then 3 power 2, 9, force will increases 9 times. What if the same case, see, hypothetical situation, R cube. First we have learnt R, then we have just now we have learnt R square. Now we learn R3. R power 3 is also not there, just for a knowledge. So in any question, in any way you can apply the same method, it will work. Now listen, we know these two are inversely proportional. If R increases, force decreases, but how many times? That is important. That is based on power. If R increases 2 times, R increases 2 times, what happens to force? How many times it will decreases? That is 8 times. How? If R increases 2 times, instead of R write 2. 2 power 3, 8. 8 times force decreases. Next up, if R increases 3 times, if R increases 3 times means instead of R write 3. 3 power 3, that is 27. Force reduces by 27 times. The same thing in a ulta way. Okay, if R decreases 2 times, if R decreases 2 times, R power 3, okay, so 2 power 3 will be 8. Force will increase 8 times. So in this way we need to understand the concept. So what is the question? The distance between the two bodies is doubled. Doubled means what? So we are going to talk about, this is the main formula. The distance between them is doubled. That means R becomes 2 times. Okay, it increases 2 times. So if this increases 2 times, we know this force will decreases, but how many times? That is important. If R square, right, it increases 2 times. 2 power 2, that is 4. Force decreases by 4 times. So what is the answer for this question? The gravitational force between them reduces by 4 times or decreases by 4 times. That is the final answer. All these things are explanation for a different case. Our next question, how does uniform circular motion differs from uniform linear motion? See, first thing, what are the things we are talking about? Uniform, linear, as well as the circular motion. So when it comes to motion, we talk about 3 things: speed, okay, velocity, acceleration. If you know these things, then okay, so whenever we talk about motion, these are the 3 things we have to talk: speed, velocity, and acceleration. So we have to write the differentiation, correct? But we are going to learn in different ways so that you will understand the complete view. Maths point of views intention is not to give the solution for a particular question. We are going to train you in all the angles. See, the same question can be asked in many ways. So we learn everything. Whatever the question they ask, you should be able to answer it. Very simple. Listen, first you need to understand the meaning of uniform. Uniform means same speed. Keep this in mind. Uniform means same speed. See, uniform linear motion. What do you mean by linear motion? That means object moves in a straight path. Linear means straight, circular means circular. Okay, so here also we have linear, here we have uniform linear. Uniform linear means moving with the same speed. Linear means we don't know. Okay, it is a variable speed. Okay, we cannot say it is increased or decreased, so we call it as variable. So uniform means same speed. Uniform linear means same speed in a straight path. Uniform circular means same speed in a circular path. Linear means we don't know, we call it as variable. So the word uniform is very much important. So when it comes to uniform circular motion, okay, we know uniform means what? Same speed, not velocity. Same speed. Okay, I'll tell you why not velocity. See here, speed remains same. Okay, remains same. Remains same. But when it comes to uniform circular motion, velocity is variable. Velocity is variable. Why? Because see, whenever an object is moving in a circular path, uniform circular path means it is moving in a circular path with a uniform speed, same speed, 40 km per hour. Okay, it is moving with a speed of 40 km per hour. So in the complete motion, the speed will be 40 km per hour. That is nothing but uniform. That is why I told you speed remains same throughout the journey, but velocity does not remain same, because two things. Velocity is a vector quantity, correct? Okay, when it comes to magnitude, magnitude may remain same. Magnitude means what? The value. Okay, 40 km per hour. It may remain same, but velocity is a vector quantity. As I told you, it also depends upon direction. Not only it depends upon magnitude, it also has a direction, right? So for every point, assume the same object, okay, is moving here. Now see, initially the direction is here. Now see, the direction is here. Now the object is here, the direction is towards here, correct? So every point the direction changes. That is why we call it velocity as a variable velocity when it comes to uniform circular motion. See, speed only depends upon the magnitude, correct? So that's why throughout the journey it is 40 km per hour. In the same way, velocity, the value magnitude is also 40 km per hour only. But for every point, okay, for every point the direction changes. If the direction changes, we know velocity is a vector quantity. It does not depend only upon the magnitude, it also depends upon the direction. Magnitude remains same, 40 km per hour. What about the direction? Direction changes every second, so it is a variable. Okay, if it is variable, then what about acceleration? Acceleration never depends upon speed, it completely depends upon velocity. Keep this in mind. Well, as what is acceleration? A difference in velocities by time, correct? So it depends upon two things. One is velocity and second one is time. Time does not depend upon the direction, so we don't care about it. So acceleration completely depends upon, see, this is the acceleration formula. It does not depends upon speed, it is always depends upon velocity. Keep this in mind. So when it comes to acceleration, you should think only about velocity, not about speed. So acceleration, we know in uniform circular motion, we know velocity is variable. If velocity is variable, acceleration will also be variable, correct? See, variable means we don't know which velocity, okay, initial or final is more or less, correct? It is variable, whether it is increased or decreased, we don't know, okay, based on the direction. So we take it acceleration as accelerated motion. Accelerated motion. And many students will think accelerated motion means the speed is increased. No, speed or velocity is increased. No, accelerated motion means variable velocity. Accelerated motion means variable velocity. Constant acceleration means, okay, constant acceleration means, see, acceleration, okay, we got, okay, we can learn three things. Acceleration is acceleration. Next, constant acceleration, zero. Okay, listen. Accelerated motion means the way it has a velocity. Acceleration depends upon only velocity. So if what do you mean by accelerated motion? That means velocity is variable. Constant acceleration means what? Many students will think constant velocity. Completely wrong. Okay, constant acceleration means the velocity is increasing at a constant rate. So velocity is increasing for every second. It will increase at the same phase, okay, same value. Okay, that position we will get it acceleration as constant. When the velocity is constant, acceleration will be zero. Keep this in mind. When the velocity is constant, acceleration will be zero. Why? Because acceleration depends upon velocity. If the, what do you mean by velocity is constant? That means initial and final velocities are same. 40 and 40 minus 40, 0. So acceleration will be 0. When the acceleration is 0, when the velocities are constant, then acceleration will be 0. This is very much important. Okay, so acceleration will be accelerated motion. What do you mean by accelerated motion? It does not mean increase in velocity. No, accelerated motion means variable velocity. Next, we'll talk about, so if you know this much about uniform circular motion, aram se you can answer. Now we'll talk about uniform linear motion. Okay, uniform means same speed and velocity. Okay, linear means straight path. Now in uniform linear motion, okay, an object covers some distance. Linear means what? Straight path. Okay, assume it has covered 10 kilometer. Okay, next, what will be the displacement? Do you think distance and displacement are same? No, distance is total traveled path. Okay, total length it has traveled. Displacement is, it is the shortest distance. The important word here is shortest distance between initial and final point. Whenever we talk about shortest point, it has to be a straight line. See, object A is here, object B is here, it goes like this. Okay, this is the, assume 2 kilometer, 4 kilometer, 6 kilometer. Okay, this is the distance it has traveled. Okay, what is the complete distance now? 12 kilometers. What is displacement? Displacement is the, okay, straight path. It is the shortest distance between point A and point B, initial point and the final point. Okay, so here at this point it is a straight line. Everywhere the shortest distance or the shortest path will be always a straight line. Keep that in mind. So when it comes to uniform linear motion, it is a straight line, correct? So here distance will be equal to displacement. So in uniform linear motion, speed remains same. Next, velocity also remains same. Here in this case, why was the velocity changing? Because at every point, okay, even though the magnitude was same, the direction was different. Here the direction is also same. See, straight path, correct, only one direction, as well as the magnitude is same. That's why velocity remains same, constant. Instead of same, we can write it as constant. Okay, remains constant. Here also we can write it as constant. Next, acceleration. So what happens to acceleration? Now see, we got to know acceleration is only depends upon velocity, not the speed, only velocity. If the velocity is constant, what will be the acceleration? Acceleration will be 0. Why? Because if velocities are constant, what I mean by constant? The same value. Initial velocity is also 40, Final velocity is also 40. You can take any number. Okay, 50, 50. If both are same, then acceleration will be 50 minus 50 will be 0. So acceleration will be 0. Okay, now we'll talk about linear motion. Here it is uniform linear, that is just linear. What is uniform? Uniform means constant speed. Linear means just moving in a straight path. We don't know the speed, okay, value of speed, whether it is constant, whether it is a variable. So always we assume it as variable. So in linear motion, speed is a variable quantity, and we know velocity is also variable. Okay, and if velocity is variable, what happens to acceleration? It will become accelerated motion. What is accelerated motion? Accelerated motion doesn't mean increase in velocity. No, it is variable velocity. When the velocity is variable, we call it as accelerated motion. That's it. Now aram se using these points you can differentiate. So what they have asked, how does uniform circular motion differs from uniform linear motion? In uniform circular motion, speed, okay, in both the case speed remains constant, so we cannot write that as an answer, because difference means there should be some difference. Here velocity is variable. In uniform linear motion, velocity remains constant. Here acceleration is it is an accelerated motion. Uniform circular motion is accelerated motion. Okay, here it is unaccelerated, zero accelerated motion. In this way you can write the answer. So you have to understand everything. Then see, now they are asking this question. Okay, write the difference. What if they ask, okay, what is the velocity? Okay, what happens to velocity in uniform circular motion or uniform linear motion? All those simple questions they will twist it. So for that we need to have the complete knowledge. Now we'll move on to 2018. So from now onwards, actual picture of physics paper you will get to know. Now listen, a half meter rod. See, before solving these solutions, okay, if you want to know the complete solution of all these things, then you should have the knowledge of complete force chapter, all the three parts, part A, part B, part C. Then only you will understand here. Okay, now we are going to understand how the board exam papers are completely different from textbook questions. That's it. So for that you need to understand the textbook questions, right? The solutions you should know. If I give you any diagram like this, you should be able to answer it. Then only you will understand all these things. See, okay, so before, what is the conclusion here? Before coming to this video, you should have the knowledge of complete force chapter. So immediately after learning the force chapter, go to the previous year papers of force chapter, then only you will understand the complete concept. So solve all the numericals, all the links are available in the description. Then come back to this one. This is previous year paper, okay, not the solution for a particular question. Now listen, a half meter rod is pivoted at the center with two weights, 20 GF and 12 GF, suspended at a perpendicular distance of 6 cm and 10 cm from the pivot respectively, as shown below. Okay, now we'll go for the question. Which of the two forces acting on the rigid rod causes clockwise movement? So you need to understand one thing. Listen, assume this weight is not there, this 12 GF weight is not there. Okay, then only because of this weight the scale is going to fall down in this way, correct? It is going to fall down. Okay, if we have a proper support, it is going to produce like this, correct? A moment of force will be like this. What kind of momentum is this? Anti-clockwise, correct? Anti-clockwise. Then they are asking clockwise. Assume this weight is not there. Because of this weight, it is going to rotate like this. What is this? Clockwise. So what is the answer for this question? That is 12 GF. And you can easily analyze like this. Left side always produces anti-clockwise movements, and right side it is always clockwise movements. Keep that in mind. Next, Is the rod in equilibrium? What do you mean by equilibrium? If you have solved all the numericals from the textbook, this is not a question for you. This is a very simple thing. Equilibrium means that is if the scale is balanced or not. The scale is balanced or not. If the scale is not balanced, we don't call it as equilibrium. So what is the question? Is the rod in equilibrium? How to find that? Very simple. LHS value, okay, anti-clockwise movement should be equal to clockwise movement. Okay, what is anti-clockwise moments? W1 x1 should be equal to W2 x2. Then these values should, if they are equal, then the scale will be in equilibrium. See, don't have to calculate and check. Now aram se you can see what is W1 20 GF, what is x1 from the weight till the fulcrum, that is the perpendicular distance. Here we have one weight, from the weight to the pivot point, that is fulcrum. Okay, that distance we call it as x2. So w1 x1, 20 into 6 120, 10 into 12 120, both the sides are equal. LHS is equal to RHS. So what is the question? Is the rod in equilibrium? Yes. Apart from yes, don't write anything. Okay, if they are asking you to prove, you can prove. Here they are asking, is the rod in equilibrium? They are not expecting any proof here. Just 1 mark question. So write yes or no. If it is in equilibrium, write yes. If not, no. That's it. No one is going to ask you any proof. So don't write one, and don't waste time on writing extra things, because you need that extra time to invest in some other questions. So focus only on the perfect answer. Precise answer should be very precise. Okay, then the direction of 20 GF force is reversed. So what do you mean by that? The direction of 20 GF force is reversed. Initially it was downward direction, now it is upward direction. Understood? This is what they meant. The direction of 20 GF force is reversed. So if do you understand all these things in some website? No, that is why maths point of view is completely different. We are not going to give you the solution. We are going to train you so that you will understand. If the question is asked in different way also, you will easily answer. So if the 20 GF weight direction is reversed, what is the magnitude of resultant moment of force on the rod? See, very simple. Because of this force, okay, because of this weight, okay, 20 GF, it is going to rotate clockwise, correct? Now, because of this one, again, because of this one, in this direction only it is going to rotate. See, this is upward direction also clockwise, downward direction is also clockwise. So then the complete total resultant moment means, what is the resultant moment? That will be addition of both. Why? Because both are in the same direction. If they are in the same direction, see, very simple. If there is a box, you are applying 10 Newton force. In other direction, applying 4 Newton force. What is the resultant force? Subtraction of these two. Why? Because they are in opposite direction. We have to subtract. If they are in same direction, assume the same force in this direction, 4 Newton, then what will be the resultant force? 14 Newton. Why? Because they are in the same direction. Here also the same principle works. See, because of this force, this weight, it is going to produce clockwise, and because of this weight, see in which direction it is going to rotate, it is also going to produce as clockwise. If both are in the same direction, we have to add them. Okay, initially when it was downward direction, what was the resultant force? Resultant force was 0. Why? Because both were in opposite direction, and in opposite direction means we have to subtract, and we know both the sides the values were equal. So 120 minus 120, resultant force would have been 0. Now they are changing the question. So if you change the direction of this 20 GF force, then what will be the resultant force? That is nothing but addition of these two. Why addition? Because they both are in same direction. We know 120 and 120, so totally it will be 240 GF. That's it. So here also they are not expecting you to calculate it. This is for 3 mark question. Write the answer directly. For if you want to show the calculation, show it somewhere and don't waste time on it. In 2018 there was only one question. Now we'll move on to 2019. Define couple and state the SI unit of moment of couple. Very simple question. See, couple. First you need to understand what is couple. Okay, couple means there will be two forces. If you have seen the concept video, you would have understood. Couple means two forces, equal and opposite forces acting on a body, but they do not share the same line of action. So this word will confuse many students, correct? So if you go to some website or some other textbook, you will see this word, they do not share the same line of action. So what do you mean by that? You will not understand that, so you will by heart it and write it. What is the use of it? Very simple. See, if an object is there, okay, here equal and opposite forces acting on a body, but here this is in same line of action, in the same line, okay, equal and opposite but in the same line. Okay, if I apply one more force, the same force here, equal and opposite, 4 Newton and 4 Newton, equal and opposite, but these two are not in same line of action. That is why it produces rotation. Okay, that is why it produces rotation. Okay, if they are in same line of action, it will not produce this rotational movement. Okay, what do you mean by couple? Couple means something which is rotating, right? So if they are in same line of action, we will not get a couple. Okay, so it should not share a same line of action. This is the meaning of couple. And we know couple and moment of force are similar but not same, and formula also remains same. Moment of force and moment of couple, force into perpendicular distance only, then the unit will also remain same. The unit for couple will be Newton meter. That's it. Our next question in 2019, a uniform meter scale. See, in one of the questions we have solved a question related to scale, right? There it was not mentioned uniform meter scale. Here it is clearly mentioned uniform meter scale. You should know the difference between meter scale and uniform meter scale. This one, half meter scale and uniform half meter scale. That is what we have learnt in this one numerical video, correct? So that is very much important, because uniform meter scale, okay, the center of gravity will be always at the center. Uniform meter scale. In non-uniform, okay, just meter scale, the center of gravity can be anywhere. So the important word in this question is uniform meter scale. So this is where, okay, at 50 we have center of gravity. This is very much important. What do you mean by center of gravity? That means the complete mass of the scale will be concentrating at 50 centimeter. Okay, why 50? Because it is the center. And why we have to take the center? Because it is clearly mentioned it is uniform meter scale. That means center of gravity is always at center, that is 50 for this uniform meter scale. If it was uniform half meter scale, the center would have been 25 centimeter. So here in this case uniform meter scale, so the center of gravity is at 50 centimeter. That means the complete mass of the scale is concentrating at center of gravity at 50. Okay, now we know we have solved many questions like this, so no need to worry about it. See, this is how we learn to understand how the question paper in the board exam will be. So in normal textbook it is about just calculation. In board exams it is about calculation as well as some thinking. Calculate the weight of the meter scale. This we can do. Okay, calculate, that means LHS, anti-clockwise movements is equal to clockwise movements, and that is nothing but W1 x1 is equal to W2 x2. What is W1? The weight on left side, that is 40. What is x1? From the weight till the fulcrum, we don't care about the center of gravity. Where is the fulcrum right now? It is at 30. So from the load, where is load? 5. From 5 to 30, what is the distance? That is 25, correct? Next, what is W2? W2 is nothing but the weight of the complete scale. Okay, that is what we are going to find. We'll write it as W2 only. What is x2? X2 is nothing but from the weight till the fulcrum. What is x1? From the weight till the fulcrum, right? This distance. In the same way, we know the weight will be concentrating at center of gravity. From here, from center of gravity till the fulcrum is x2. How much is that? 50 minus 30, that is 20. Okay, if you want W2, that will be 40 into 25 by 20. 0 0 2 1s are 2 2s are, so it will be 50 GF, that is the weight of the scale. That's it. We'll go for the next one. Which of the following option is correct to keep the ruler in equilibrium? What do you mean by equilibrium? That means it is in balanced state. Okay, it should not fall on one side. Then when 40 g of weight is shifted to 0 centimeter, see now it is in equilibrium, correct? Now it is in equilibrium because the scale is getting balanced. What they are telling, this 40 g of force, they are going to move towards 0 centimeter. They are going to move towards 0 centimeter. Then what happens if you move this one towards 0? The scale will fall this side only, correct? The scale will fall this side only. So what we have to move, we have to move this fulcrum little bit this side. Now listen, if the weight is moving this side, the scale is going to fall. But what do we want? We have to maintain it in a equilibrium. That means even though it is moving this side, we have to make sure the scale should not fall either side, correct? Either any one of the side. So what we have to do, we have to move this fulcrum this side only, then only it will not fall, it will be in equilibrium. So what is the question? Which of the following option is correct to keep the ruler in equilibrium when the 40 g of weight is shifted to 0 centimeter mark? If this is moved towards 0 centimeter mark, okay, F means the fulcrum. Where should we shift this one? If you move that the fulcrum that side, again it is going to fall. It cannot be in equilibrium. Where the load is moving, that side fulcrum should move. Keep this in mind. To keep the equilibrium, now it is in equilibrium. Now if I move this one this side, obviously this side the weight will be more, it will fall this side, correct? So we have to move the fulcrum F in the same direction. So answer for this question, F is shifted towards 0 centimeter. F is shifted towards 0 centimeter. That's it. Now we'll move on to 2020. Listen, define moment of force. Write the relation. That is the second question. First we'll answer this question. Define moment of force. See, when it comes to moment of force definition, we only care about two things, that is force and the perpendicular distance. If those two are mentioned with a proper English sentence, that is enough for us to get the full marks. Okay, so this is how, while I'll correct the papers in the board exam, this is how they will give us the key answers. We need to understand, we need key words. That's it. Force, okay, magnitude of force and perpendicular distance. If both are there, you will get the complete mark. But from the textbook, we will learn the definition. Define moment of force. So this is the answer. The moment of force is equal to the moment of force as other name, correct? That is torque. Okay. Then it is equal to the product of magnitude of force. Magnitude means what? That is the number. Okay, 20 Newton, 44 kg. 50 grams, all these numbers are called magnitude. Okay, it is the product of magnitude of force and the perpendicular distance. Now we'll go for the second one. Write the relationship between SI and CGS unit of moment of force. Are they asking you to state the SI and CGS unit? No, right? They are asking the relation. That what do you mean by relation? 1 Newton meter is equal to, okay, 1 SI unit is equal to how many CGS unit? So they are asking the relation between SI and CGS. First, SI, what is the SI unit of moment of force? That is Newton meter. 1 Newton meter is equal to dash 9 centimeter. This you should write. This is the relation they are asking. Answer is 10 power 7. Okay, how? This is very simple. Listen, 1 Newton is equal to 10 power 5 dyne. 1 meter is equal to 10 power 2 centimeter. Now 1 Newton meter here, 10 power 5 dyne and 10 power 2 centimeter. So they are product multiplication, right? So whenever we multiply, the powers will get added. 5 plus 2 is 7. So 1 Newton meter is equal to 10 power 7 dyne centimeter. That's it. Our next question, with reference to the direction of action, how does the centripetal force differs from centrifugal force during uniform circular motion? Whenever there is a uniform circular motion, we know both centripetal force and centrifugal force will be there, and we know centripetal force is real force and centrifugal force is fictitious. Fictitious means what? It is not a real force. Okay, now we'll go for the question. With reference to the direction of action, how they differ, correct? We know centripetal, this is a question, okay, sub question is centripetal is towards the center. It is always towards the center of rotation. Okay, CNTE are also fine, CNTRE also fine. UK and US English, that's it. Centrifugal. Centrifugal force is always away from the center. Anything is fine. Okay. So answer for first question is done. So you need to understand centripetal is always towards the center. Okay, that acts like a radius of the uniform circle. Okay, see, if you take this as a movement of object in circular path, centripetal force will be towards the center. It is nothing but the radius only, correct? Centrifugal will be away from the center. Next, centrifugal force, the force of reaction of centripetal force. So in some websites you will get the answer as no, you will write it. But what if the same question is twisted in other way? If you don't understand the question, if you just by heart the answer, there is no use. Understand it, it is very easy only. Centrifugal force is the force of reaction of centripetal force. That means centripetal force is action, centrifugal force is reaction. Do you think that is correct? No. So because of centripetal force, centrifugal force is not generating. Both are completely different. So they are asking, if the centripetal force is action, do you think centrifugal force is a reaction? No. If this is an action, if this is a reaction, that is nothing but Newton's third law. So when it comes to centripetal and centrifugal force, Newton's third law will not work. What is Newton's third law? For every action there will be opposite reaction. Because of centripetal force, centrifugal force is not there. So answer for this question is no. Okay, centrifugal force is not a reactional force of centripetal force. Both are not related. Then see, compare the magnitude of centripetal force and centrifugal force. See, in this question we have clearly mentioned centripetal force is towards the center, centrifugal force is away from the center. But in here part, see, they are asking us to compare the magnitude. What do you mean by comparing? Comparing means ratio form. You should know how to write the answers in ratio form. Whenever you are writing the answer, see, answer for this question is 1:1. Even though they are opposite in direction, but they are equal. Okay, equal magnitude but opposite direction. So whenever it comes to centripetal and centrifugal force, if this question is there, okay, compare the magnitudes of centripetal and centrifugal force, you have to write the direction also. Okay, what is the direction? You should not write direction in the bracket. Direction means opposite in direction. If you don't write this one, you will not get the 1 mark. Okay, the answer is this one. See, for other questions, if they are asking you to compare the magnitude, the value is enough. But when it comes to centripetal and centrifugal force, in the bracket you have to write opposite in direction. This is very much important only for this question. Okay, so if they are equal and opposite, you have to write 1:1. If you write their magnitudes are same, that is also wrong, because they are asking you to compare. Compare means what? Write the answers in the ratio form. They are equal and opposite. Okay, towards the center, away from the center. They are opposite, but they are equal. When the values are equal, okay, the answer will be 1:1. Our next question: what is the position of center of gravity of triangular lamina? So triangular lamina is nothing but almost like a triangle. Okay. So what is this position of center of gravity? This is a simple question, right? You can easily by heart and answer it. So why the point of, we have so many shapes. Okay, in our textbook you have to by heart the center of gravity position. Okay, or else you can understand it in this way. What is, see, so this is the center of gravity. Okay, the point of intersection of medium. The point of intersection of median. Okay, medians. Next, so this is nothing but centroid only. In math, you know, this is nothing but centroid. Then we'll go for the second sub question. This is very much important. For this one, part A, okay, first sub question is about something you can by heart and answer. Second sub question, without knowledge you cannot answer. Many students for second question, they know the answer but they don't know why. That is very much important. See, when this triangular lamina is suspended freely from any vertex. Okay, what do you mean by vertex? This point, this point, this point, correct? Assume this triangular lamina. Okay, I'll made a hole in the vertex and I'll made it to suspend it freely. Suspend it freely on one of the vertex, any vertex. Okay, what is the moment of force produced by its own weight in its rest position? Whenever they see rest position, they'll see, if what do you mean by moment of force? Rotation, correct? Rotation is nothing but moment of force. As a rest position, there will be no moment of force, so answer will be 0. Okay, answer will be 0. This is one way to answer it. Okay, but are they asking why? Then don't write 1. Okay, if they are asking reason, then you can write the reason. But what they are asking, what is the moment of force produced by its own weight? 0, because it is rest position. And what is the actual meaning? Listen, here whenever you made a hole here and it is hanging now, okay, if it is rotating, we have a moment of force. How it can rotate? One, it is because of force applied. Here the what now it is at rest position. What kind of force is there? If something is hanging, in the first question only we understood, if something is hanging, the weight of the body will act as a force. Weight of the body will act as a force. What is moment of force? Do you think moment of force depends upon only force, or as well as perpendicular distance? This one, force as well as perpendicular distance. We have force, but we don't have perpendicular distance. That is why moment of force will be 0. Okay, understood? We have force here. Okay, it is hanging, but it is not moving, correct? We have a force here. Force is nothing but the weight of the object, but we don't have the perpendicular distance. So if perpendicular distance is 0, what is moment of force? Force into perpendicular distance. Force is there, that is weight of an object, correct? Moment of force is equal to force into perpendicular distance. Force is there, that is nothing but the weight of the object. Perpendicular distance is not there, that is 0. 0 into anything is 0. That's why moment of force is also 0. Our next question, the diagram shows wheel O pivoted at point A. Pivoted at point A. Pivoted means what? Fixed at point A. 3 equal forces. Equal forces. This is very much important. Equal forces. Why it is important? You will definitely get to know. Yeah, 3 equal forces, F1, F2 and F3. This is F1 and F2 and F3. Okay, are at point B on the wheel. So if one force is applied, assume F1 is applying right now, so it is going to rotate. F2 is applying, again it is going to rotate. F3 is applying, it will rotate. Now what is the question? Which force will produce this maximum moment of force? Okay, what do you mean by moment of force? Moment of force is equal to F into D. In the question it is clearly mentioned forces are equal. Forces are, all the 3 forces are equal. Then perpendicular distance. What do you mean by perpendicular distance? From where you have applied the force, this point, from there to the pivoted point till here, correct? So what is perpendicular distance? Where we have applied the force, the distance between the force applied and the pivoted point. See, all the 3 forces are applied, okay, in the same point, and the distance, see, for F1, what is the perpendicular distance from this point to A? F2 from this point to A. For F3, and from the same point to A, perpendicular distance is also same. Okay, if moment of force, okay, force is also same and this perpendicular distance is also same, and they are asking which will produce, which force will produce us, okay, maximum moment of force. If all the values are same, then how we can answer it? Very simple, that is based on angle. Okay, for 90-degree angle, for a 90-degree angle, it produces maximum moment of force. Keep that in mind. Only for 90-degree. Okay, 90-degree angle, it produces maximum moment of force. Maximum moment of force. Now see the angle. Now what angle we are talking about actually? From the force, okay, the angle between the force and the perpendicular distance. Now we'll come from this one. From F, okay, F3, draw a angle like here. From A to B like this. What is the angle now? What is the angle from F? See, from F3, this is the complete angle. We know, we got to know 90 degree. It will produce us maximum moment of force. F3, and what is the angle between force F3 and perpendicular distance? That is nothing but almost like a straight line. So that is 180 degree. That is wrong. F2, see here, from F2 there is a line. What is the angle between them? See, it is more than 90. That is also not correct. But F1, it produces 90. Correct? It produces 90 degree. So F1 is the force which is going to produce us maximum moment of force. And give the reason for your answer, because you can aram write the angle between the force F1 and the pivoted point A, the perpendicular distance, that is A, okay, is 90 degree. Our next question, what should be the angle between the direction of force and the direction of displacement for the work to be negative? So what do you mean by that? Work should be negative. This is the condition. So what is the angle between them, they are asking. See, angle means what? Where if I apply force in this direction, if the object move in this direction, okay, if the object move in this direction, if you extend this one line, this angle they are talking about. See, this is the where I am applying a force. The object is moving in this direction. So angle between them is this one. If I apply a force in this direction and the object moves in the same direction, what is the angle between them? 0. Here some angle is there, but they are asking what is the angle. So for what, see, this one, work done is equal to what? Work done is equal to Fs cos theta. So definitely it does not depend upon force value and the displacement value. These are just magnitudes. This will not give you positive or negative. The only thing it is going to give you the negative or positive value is cos theta. When the cos theta will be negative, that is cos 180 degree. Correct? 180 degree. What is cos 180? That is -1. So we are going to get the work done as negative. This we have already learnt, okay, in the concept video, correct, as well as in the solution video. See, work done negative, it does not depends upon force and displacement. It depends upon the angle. If both are in the same direction, see here, what is the angle? 0. Here some angle is there. When it is opposite, see, when you apply a force, okay, force is in this direction and the displacement is in opposite direction. So okay, if the displacement is in this direction, see, you can take this as displacement and the force is in this direction, then angle between them is 180 degree. Opposite means what? 180 degree. Same direction is 0. Opposite direction is 180 degree. So when this is possible, whenever we talk about frictional force, this condition is possible. Okay, so in this way we need to understand. See, what is the answer required in this question? That is 180 degree. For 180 degree angle, work done will be negative. For 90 degree angle, work done will be 0. For any other angle, work done will be positive. Keep this in mind. Okay, for 180 degree, the work done will be negative. Our next question, a meter scale of weight 50 gf can be balanced at 40 centimeter mark without any weight suspended on it. So meter scale, this is not uniform meter scale, it is just meter scale. This is the very important point. Meter scale means center of gravity will not be at the center. Uniform meter scale means center of gravity will be exactly at the center. So it is clearly mentioned, it is just meter scale. So weight of the meter scale is 50 gf, can be balanced at 40 centimeter mark without any weight balanced on it. Okay, if you keep a fulcrum, okay, support means what? Fulcrum at 40 centimeter, the scale will get balanced. Even though it is from 0 to 100, the scale will balance itself without any weight suspended on it. Okay, no, without weight it will balance. That means it will be in equilibrium. Now if we'll go for the question, if the ruler is cut at its center, then state which part. 0 to 50, exactly at 50 I am going to cut it. Okay, at the center we are going to cut it. 0 to 50 and 50 to 51 to 100. 2 pieces we will get. Okay, if the ruler is cut at its center, then state which part. 0 to 50 and or 50 to 100 centimeter of the ruler will weigh more than 25 gf. Very good question. Okay, so see, now here we need to understand in a meter scale without balancing, okay, without weights, where we can balance it at 40 centimeter. That means center of gravity is at 40 centimeter. Keep this in mind. This is what you need to understand. So see, first you need to understand where is the center of gravity and what is center of gravity, then only we can answer all the remaining questions. See, a meter scale means what? 0 to 100 centimeter. If 50 gf weight, the complete weight of the scale is 50 gf, then balanced at 40 per centimeter mark without any weight suspended. Without any weight means without any weight it can be balanced. Balance means it is in equilibrium. Okay, that means what? Without weight means at whatever the support fulcrum we are keeping, there we have the center of gravity. So fulcrum is at 40 centimeter, that is clearly mentioned in the question. Okay, so CG is at 40. What is CG? Center of gravity. That means the complete mass of the scale will be at 40 centimeter. The complete mass of the scale will be at 40 centimeter. That is why it is getting balanced. Okay, so the complete 50 gf of the weight of the scale is at 40 centimeter. Now we got to know. Now see the question. If the scale is cut into half exactly at the center from 0 to 50, okay, here if you cut this piece and 50 to 100 one more piece, then which will weigh more? See, we know if you cut exactly at 40, both will weigh equal. See, understand this one. If you cut exactly at 40, both the sides 0 to 40 and 40 to 100, even though the length is more, both will weigh at the same, correct? The weight will be same. Why? Because the center of gravity is at 40. That means both the sides weight will be same. Now where they are cutting? They are cutting at 50. They're cutting at 50. We have, if you cut here, it will have equal weights. If you cut little that side, that means this side weight is more than the that side. So answer here is 0 to 50 centimeter will weigh more. This is how we need to understand. Okay, so if you get any single doubt or a confusion, just go back and watch it. You will definitely understand. Second one, what minimum weight, okay, placed on the meter ruler can be balanced the ruler at pivoted point is at center. See, what minimum weight placed on its meter rule. So now you need to understand the question properly. Okay, see, what minimum weight placed on the meter ruler can balance this ruler when it is pivoted at its center. Initially the pivoted point at 40 without weights. Now what they are telling, they have to pivot it at 50 centimeter. Okay, 50 centimeter. What happens if you move the fulcrum to 50 centimeter? This side is it has more weight, so it is going to fall. So we are going to keep one weight, so that we have to make sure it is at equilibrium or it is at balancing state. If fulcrum is moved from 40 to 50, so this is going to fall this side, correct? And we are going to add one weight to balance it. So we'll add one weight somewhere here, it will balance, correct? Completely wrong. It is already falling this side. If you add one more weight on the same side, it definitely falls faster way. Okay, so you have to add the weight here. Have they mentioned where we have to place the weight? No, right? If it is not mentioned, always place the weight at the end. Always place the weight at the end. Why? Because it is clearly mentioned what minimum weight. If you want to place a minimum weight, the distance has to be bigger. See, if you keep the weight here, the same weight here, it is not going to balance it. Why? Because it is a minimum weight. If you are going to balance the scale with the minimum weight, the distance has to be longer. The longer distance is nothing but the end of the other side. Why we are not placing the load this side, weight this side? It is because of the center of gravity is at 40. It is going to fall this side only. Okay, now if I place the weight the same weight here, again it is going to fall faster. We have to balance the scale, means we have to place the weight that side. They have clearly asked minimum weight. Minimum weight means always we have to place the load at the other end. Okay, completely at 100 centimeter. Now we know the position of the weight. Okay, we have to find the what is the minimum weight. Very simple. W1 x1 is equal to W2 x2. This side we don't have weight only. This side weight is nothing but okay, weight of this scale that is given in the question, that is nothing but 50 GF. See, you don't have to mention the unit. We know W1 x1 is related to LHS, left hand side, correct? So this side is the center of gravity at 40, correct? Center of gravity is at 40 centimeter, that is 50 GF. This is very much important. These things are very much important to solve the numericals. 50 is done, and x1, center of gravity is at 40, fulcrum is at 50. What is x1 distance value from the load to the fulcrum? Load is nothing but 50 GF. Where is that 40? From the 40 to fulcrum it is 10. What is W2? That is what we are going to find. What is x2? See, fulcrum is at 50, load is at 100. 100 minus 50, that is 50. So 50 into 50 by 50 cancels. So W2 is equal to 10 GF. That's it. What is the minimum weight we are going to place? That is 10 GF. Where we are going to place? That is at 100 centimeter. That's it. Now we'll solve questions from 2024. A non-uniform beam of weight 120 Newton pivoted at one end is shown in the diagram below. Calculate the value of F to keep the beam in equilibrium. Okay, see, when you see this diagram, you will get really confused. Okay, but if you think properly, if you have the concept, this is a very simple question. Okay, compared to the previous questions, this is very simple question. Listen, a non-uniform beam of weight of 120 Newton. Okay, listen. Where is that 120 Newton? Here, and that point is considered as CG. What is CG? Center of gravity. So center of gravity means what? The complete weight of the object is concentrated at this point. Okay, so this is one weight. This is the pivoted point O. From pivoted point O and the center of gravity, how much we have? That is 120 Newton. The distance is given. Okay, W1 x1 is given. Then this distance is given, that is x2. We need to find the value of W2. That's it. Very simple question. Compared to the previous logical questions, this is very simple, but the diagram is little scary, but you should not get scared. Okay, if you know the concept, aramse you're going to apply it and get the answer. So if we see, we need to find W2. That's it. See, center of gravity, that is 120 Newton. For first left side, whatever the weight is there, this is left side weight and this is a right side weight, right? So W1 x1 is equal to 120 into 0.2. You don't have to convert into SI units. Okay, you can keep it like that. This is here, this is SI units. Okay, this is proper. If they give you kg and centimeter, you don't have to convert it, because on both the sides we have same units, that will get cancelled. Okay, now W1 is equal to 120. What is x1? From the weight till the pivoted point, that is nothing but fulcrum. Pivoted point O or fulcrum point O. What is this distance? That is given here, that is 0.2 is equal to W2. We need to find the value of F, correct? Value of F is nothing but the force to keep the beam in equilibrium. That means we have to keep a weight, okay, that is nothing but force, okay, to be in equilibrium. What do you mean in equilibrium? That is balanced. Okay, so that is what we need to find into x2. How much? What is x2? From the force, okay, till the center of gravity, correct? No, completely wrong. X1, x2 is always from the pivoted point. So x1 is from pivoted point to weight 1. Okay, that is 0.2. We have written it here. And what is x2? From the pivoted point or the fulcrum till the second weight. Okay, that is F. How much is that? That is 0.8. While taking these values, you have to be a little careful. Sometimes assume the same value. Okay, assume it is given from here to here, 0.8. So what is x2? From the weight till the fulcrum or pivoted point. So assume this value is given only from here to center of gravity to here, 0.8 plus 0.2 we have to take. Okay, if they have mentioned like this, see, if they have mentioned like this, we have to take 0.8 plus 0.2 as 1 year complete. Okay, we have to add it. Anyhow, it has given directly You don't have to take it. Okay, you have to take it from pivoted point to this one second weight. Keep that in mind. All the distances x1 x2 should be from pivoted point. Okay, now W2 is equal to 120 into 0.2 by 0.8. 2 ones are 2 fours are 4 ones are 4 30s are. So W2 is equal to 30 Newton. Why it is in 30 Newton? Because another weight, first weight was in Newton, that is why second weight is also in Newton. Our next question in 2024, it is very simple and logical question. Define the center of gravity. Do you think this is a logical question? No. The second part is logical question. This is just a definition. First we'll understand the definition. See, when it comes to the definitions, we have to be very careful. For maximum marks of 80 or 100 marks paper, maximum of 2 to 3 definitions will be asked in the board exam. Now define center of gravity. Center of gravity of a body is nothing but a point. Okay, it is a point where algebraic sum of moments of weights of all the particles in the body is 0. Okay, what do you mean by that? If you take an example of an object, okay, assume this is the center of gravity. Okay, anyhow aram se we can by heart, but if you understand, there is no need to by heart. So it is a point of a body where algebraic sum of moments of weight, and I told you what is center of gravity. The complete weight of an object will be concentrating at that point. That means whenever you add all the weights, algebraic sum of moments of weight, okay, it will be 0. Whenever we add everything, it will be 0. That point we call it as center of gravity. Our next sub question: a hollow ice cream cone has height 6 cm, h is equal to 6 cm. Where is the position of its center of gravity from its broad base? From where? Base. This is very much important. First we will try to answer this question, then I will teach you how the same question can be twisted in many other ways. Now listen, from the base, right? This is very much important. From the base, okay, from the base it is h by 3, so that is 6 by 3 is equal to 2 centimeter. This is the final answer. Done. Now the same question, how it can be twisted. This is the hollow cone. See, the word hollow and solid, it is very much important. In the question it is clearly mentioned it is hollow cone. If it is solid cone, the formula would have been different. Okay, so you have to be very careful with the hollow cone or solid cone, and is it from the base or from the vertex? That is also very much important. Once you get to know it is hollow, this is the formula. Okay, that is wrong. Once you get to know it is hollow, we have to see whether it is from the base or from the vertex. Okay, this is from the base. So in this question it is clearly mentioned from the base. So this is the correct formula. If the same hollow cone from the vertex, if they ask the question, same question from the vertex, then the formula will be different. We learn how it is different. See, this is the center of gravity and this is the complete height of the cone. Okay, this height is h by 3 from the base. From the base it is h by 3. From the vertex means this one. Okay, from the vertex how much? H minus h by 3. See, complete height is h. For hollow cone, center of gravity from the base is h by 3. Okay, if we want from the vertex, okay, if we want from the vertex, see, h by 3 is nothing but only this much. Only this much is h by 3. If we want it from vertex, then h minus h by 3, h minus h by 3, this will be 2h by 3. So this is the formula for the same hollow cone if they are asking the center of gravity position from the vertex. This is from the vertex, this is from the base. That's it. Okay, in the same way, if we go for a solid cone, see, if this is, okay, h, complete height, and the center of gravity will be h by 4 from the base, okay. If the same question, see, this is for solid cone. Okay, solid means inside it will not be empty, hollow means inside it will be empty. Now for a solid cone, from the base, what is the center of gravity formula? H by 4. Then see, h by 4 is this much. What is the center of gravity from the vertex? That means this side, h minus h by 4, that will be 3h by 4. So see, this is the hollow cone. So a hollow cone from the base h by 3, and the same hollow cone from the vertex, it is 2h by 3. The same question, solid cone from the base it is h by 4, from the vertex it is 3h by 4. So these things you have to be very careful. Whether it is, if it is a hollow, you should not think for a hollow we have only one formula. No, from the base it is different formula, that is h by 3. From the vertex it is 2h by 3. In the same way for solid cone also, h by 4 and 3h by 4. Only for this cone we have these kind of different formulas. Now we have one more question. This is the first question. Second question, will its position change when it is completely filled with honey? Okay, right? Yes or no? Okay, listen. What happens if you fill the honey with honey in the hollow cone? Hollow cone, see what do you mean by hollow cone? Hollow cone means inside it is empty. Whenever you fill something, okay, in the hollow cone, inside it will not be empty, it is filled with honey. So this hollow cone will be converted into a solid cone. Now after converting, after you fill the honey, okay, inside that hollow cone, do you think the center of gravity changes? Obviously, just now we have learnt the for a hollow cone and the solid cone we have a different formula, correct? So that means center of gravity changes when it is converted from hollow to solid cone. So will the position of center of gravity changes when it is filled with honey? Yes. Why? Because, so answer is yes. You should not say anything, you should not write anything. Okay, yes, it will not change, no, it will change. All those simple silly mistakes you should not do. Okay, so whether it is very simple, in the question only they have clearly mentioned yes or no. Yes, you can write yes or no, okay, based on your understanding. Will the position of center of gravity changes? Yes. Why? Because if they ask you why, then only you're going to write the reason. Reason will be whenever we fill something, okay, in a hollow box or hollow cone, it converted into solid cone or solid box. That's it. Now we'll move on to 2025. A non-uniform kite is hanging freely from the branch of a tree as shown. See, from a branch of a tree, a non-uniform kite is hanging. Study the figure and answer the following. What is the answer the following the questions? A. Fill the blank dash. PQRS is the most possible position of center of gravity. Okay, out of PQRS, which is the most probable center of gravity? Very simple. The answer is Q. Correct? Completely wrong. Q is the center of this the shape, but it is not the center of gravity. There is no rule that center of gravity should not be at the center. Okay, the answer is R. Why? Because see, center of gravity, we can go for the formula. If this is not related to formula, very simple, center of gravity will always be in the line of suspension. Center of gravity will always be in the line of suspension. So if you extend this line, see, so line of suspension means this line where we are hanging the object. Okay, assume if you take a vertical this one lamina, triangular lamina, if you make a hole here and suspend it, the center of gravity will be in this line. Okay, if you take any different shape, if you make a hole here and hang it, okay, the center of gravity will be in this line. So in the same way it will be in the same line. Second question, support your answer. Okay, whatever you have written in A, okay, we have to write a reason simply. Reason is very simple. Okay, center of gravity will be always in the line of suspension. That's it. Now, if the same question, can it be twisted? Okay, now assume we are going to place a small piece of clay, okay, somewhere here, somewhere here. They are going to place a small piece of clay. Then do you think the position of center of gravity changes and where it will go? Very simple. See, do you think the center of gravity changes? Yes, it will change. See, we are not changing the shape, we are changing the distribution of mass. What are the factors of center of gravity? One is shape, the second one is distribution of mass. What do you mean by distribution of mass? Okay, where there is more mass, there will be center of gravity. So here we have placed one clay here, correct? So the center of gravity from R, it will try to move down, but in the same line. Okay, it will be in the same line, but it will move down because we have more mass at the bottom part. So what is the answer? Center of gravity will change whenever we place a clay. Okay, anywhere if you place it here, the center of gravity will try to move in this direction. Okay, and if you place a clay here, don't you think this kite is going to rotate automatically? Whenever you place a small clay here, this automatically will rotate. Okay, then the center of gravity will change and it will be in the same line. That's it. Our next question. Akash takes uniform meter scale and suspend a weight of 2 Newton at one end X and a weight of 5 Newton on the other end Y. He then places the ruler horizontally and on a knife edge placed at 70 centimeter from X. 70 centimeter from X. This is very much important. Draw the diagram of the arrangement and calculate the weight of the ruler. Simple, very simple. First we'll draw the diagram. Okay, we can take one line, that is enough. Okay, so uniform meter scale, it is not just meter scale, uniform meter scale, that is very much important. Why it is important? Because in uniform meter scale, center of gravity will be exactly at the center, that is nothing but 50 centimeter, that you should know. So in uniform meter scale, this is 100 centimeter. Now, so once it is done, scale is done XY, suspends a weight, in the first line suspends a weight of 2 Newton, 2 Newton at one end X. So we call it as X this one and Y here. You can name it ulta also, X there and Y here, everything, the center. Okay, the weights will change and the diagram will change, that's it. But you can take anything as X, anything as Y. So suspends a weight of 2 Newton at one end. End means what? At this complete end. Okay, how much we are placing? 2 Newton and a weight of 5 Newton on the other end Y. End means what? At the edge. So here we are placing 5 Newton weight at the end Y. He then balances the ruler horizontally and keeping the knife edge placed at 70. Knife edge is nothing but the fulcrum. So this is 50, center of gravity. Why say 50? Center of gravity is at 50 because it is uniform meter scale. In just meter scale, center of gravity will not be at 50, it will be anywhere around 50. Now it is uniform meter scale, so the center of gravity is 50 centimeter. Now we are keeping the knife edge. Knife edge means fulcrum at 70. At 70 we are keeping the fulcrum. This is 70 centimeter. Now the diagram is done. We have to calculate the weight of the ruler. What do you mean by weight of the ruler? Weight of the ruler is nothing but the weight at center of gravity, correct? If you have seen the numerical videos, then you would have understood what is the importance of center of gravity. Center of gravity means the complete weight of this scale will be focusing on this point, and that weight, what is the weight that we are going to find? See, now the diagram is done. See here, left side, from the fulcrum left side we have two weights, and the right side we have only one weight. Out of two weights, one weight is given, other weight is not given. That is what we are going to find. So left side we have two weights, so W1 x1 plus W2 x2. Why we are writing two weights on the only left hand side? Only because we have two weights, one is given, second one is center of gravity, that is nothing but the complete mass of the weight of the scale, that is what W2, and x2 we know from this weight to fulcrum. is equal to only one weight, that is W3 X3. What is W1? W1 is nothing but this weight. X1 is from this weight to fulcrum. All the distances are calculated from the fulcrum. Keep this in mind. W1 is 2. X1 is from 0 till fulcrum. Okay, what is that? That is 70. So write it as 70 plus. What is W2? That is the weight at center of gravity. That is what we need to calculate. That is nothing but the weight of this scale. So we'll write it as W2 into 20. How I wrote 20? From center of gravity. This is the weight, right? From here to here, what is the distance? That is 20 is equal to W3. W3 is the other weight, that is 5 Newton. What is the X3 value? From this weight till the fulcrum. What is the distance? This is a 70. This is 100. 100 minus 70, that is 30. So this will be 140 plus 20 W2 is equal to 150. So 20 W2 is equal to 150 minus 140, that will be W2 is equal to 10 by 20, that is 0.5 Newton. So what is the weight of this complete scale? That is 0.5 Newton. See, diagram we have wrote this one. This is not given in the question. They ask us to write. So this question is for 3 marks. Now we have completed all the questions from the chapter 4. This is previous year papers. This is from 2017 to 2025. Why not before 2017? Why? Because the questions were very much direct, logical questions were less. But now, okay, from 2018 onwards, the logical questions are more than the direct questions. And the syllabus point of view, whatever the syllabus we had before 2017, that is not the same thing now at the present case. That's why. And why not before? Okay, beyond 2025, because this is the 2025. Okay, this is the year 2025. We didn't get the 2026 paper. That's why from 2026 onwards, we'll try to solve all the papers completely. Now we have understood. See, the main difference between some website and the batch point of view is very simple. There you will get the only solution. Many students will by heart it. They don't understand the question only. But here we have taught you the complete procedure, proper procedure, and how they can twist the same question in a different way. All those things are very much important, because we know in board exam they are not going to repeat the questions. Okay, if you take from 2017 to 2025, we cannot even see the same question exactly same, okay, in one of the papers. They have not taken any question from any of the papers. So every year they are going to create the questions. For the creating the questions, we need to have the complete knowledge. That is what we are learning. So before this previous year videos, you need to have the complete knowledge about that particular chapter. So what you can do, from the fourth chapter, study from fourth chapter A, B, C, all the 3 parts. The concept, first understand the concept, solve the theory questions, and then the numericals. Once you get all these things from all the parts of the fourth chapter, then this video will be really helpful to you, because they from those videos, concept, numericals and theory solutions, will get the complete knowledge. Here you are going to understand how the board exam questions are completely different from the textbook questions. Then if you apply the same logic, sometimes you may go wrong. That is why we are teaching you how to solve it. So to solve these questions, you should have the prior knowledge. If you don't have that, all the links are available in the description box. If you go there, you will understand in a easier way. All the chapter wise playlists are there. If you want force, just tap on the force, then you will get the complete videos related to that. In the same way, you can jump from any video to any video, any chapter at any time. So in this way, if you understand, then you will have 80 to 90% of the knowledge. Remaining knowledge, we are going to get it from logical and application expected questions. How I can say it is expected? So every year they will release specimen paper and competency based question papers. So using those two, we have created chapter wise. Again, it is chapter wise, just to make sure you are learning the complete concept, okay, properly. After this one, directly go to logical and application. There you will get the complete knowledge about this 4th chapter. Thank you.